Welcome to Math 1400, Nunez Community College. Today's section will be section 2.4. 2.4 is the sum and difference formulas. Now, so far in this course, we have learned about the sine, the cosine, the tangent of angles on the unit circle that we know. 45 degrees, 60 degrees, 90 degrees. And we can find the values of each of those because we've memorized it and we've shown how to derive it. But we're limited to those angles. The sum and difference formulas are going to allow us to take those angles and add them together or subtract them to make new angles, and we'll be able to find the value of those. So this is called the sum and difference formulas. And let's look at what they are. The first thing we have is the cosine, and we'll do the cosine of a sum. So we'll call the angles alpha and theta. So we have the cosine of alpha plus theta. The cosine of alpha plus theta is going to be the cosine of alpha times the cosine of theta minus the sine of alpha times the sine of theta. And both alpha and theta are going to be angles that we do know. We also have the cosine of a difference, alpha minus theta. That's going to be the cosine of alpha times the cosine of theta plus the sine of alpha times the sine of theta. Again, nothing more than changing the signs for the difference of the sum and the difference. We also might as well keep on going and do the sine of alpha plus theta. The sine of a sum is going to be the sine of alpha times the cosine of theta, keeping the same sign, so plus the cosine of alpha times the sine of theta. The difference of a sine, the sine of alpha minus theta, is going to be the sine of alpha times the cosine of theta minus the cosine of alpha times the sine of theta. And then the tangent, being that it's sine over cosine, we're going to have tangent of alpha plus theta. That's going to be the tangent of alpha plus the tangent of theta over 1 minus the tangent of alpha times the tangent of theta. A little bit different. And then, of course, the tangent of a difference, alpha minus theta, is going to be tangent of alpha minus the tangent of theta over 1 plus tangent of alpha times tangent of theta. These formulas are known as the sum and difference formulas, and it's of the trig functions that we're going to use. So now let's look at an example and how to use them. Suppose I have the cosine of, in example number 1, suppose I have the cosine of 15 degrees. The cosine of 15 degrees. It's going to say find the exact value. By exact value, it means they're not looking for a decimal. If we have a radical square root, we're going to keep it as that. The first thing we have to do is know how can we take angles that we know and actually make 15 degrees out of it. Well, I'm going to write this as the cosine of 45 degrees minus 30 degrees. I know the cosine of 45 and I know the cosine of 30, so we're going to do 45 minus 30. So now we have what? The cosine of alpha minus theta. So the cosine of 45 minus 30 is going to be the cosine of 45 times the cosine of 30, opposite sign, so plus the sine of 45 times the sine of 30. Each one of the four things being values that we know. We know that the cosine of 45 is the x value at 45 degrees. The x value, or the x part of the coordinate, is the square root of 2 over 2. The cosine of 30 is the x value at 30 degrees, which means it's the larger of the two of the ordered pair. So this is going to be square root of 3 over 2, plus the sine of 45. Well, the sine and the cosine of 45 is the same values of the ordered pair, so it is also, again, square root of 2 over 2. And then the sine of 30 is the y value at 30 degrees. The y value at 30 degrees is the smaller of the two, so it's 1/2. This is putting all of the values together for the difference of a cosine. Now what we have to do is our order of operations to make sure that we condense this. Square root of 3 times the square root of 2 is the square root of 6 over 2 times 2 is 4, plus the square root of 2 times 1 is the square root of 2 over 4, otherwise known as the square root of 6 plus the square root of 2 over 4. This would be the cosine of 15 degrees. Again, we're taking angles that we know, we're putting it into the formula, we know the values of each one of the things that we're putting in, and we simplify it. This is the exact value, we have to leave it as radicals. In example number 2, we have another one, but this one is going to be in radians. Radians is a little harder to think about what the sum or difference is going to be, but suppose we have the sine of 7 pi over 12. The sine of 7 pi over 12. So we have to know, is this a sine of a sum or a sine of a difference? Well, 7 pi over 12 is larger than halfway, which is 6 pi over 12. So I'm going to say that this is probably going to be pi over 3 plus pi over 4, but let's make sure. We know that we have 7 pi over 12, so I need two things that we know to equal 7. That would probably be 3 pi over 12 and 4 pi over 12. 3 plus 4 is 7. Well, 3 over 12 would equate to 1 over 4, or pi over 4, because 3 goes into 12 4 times. And 4 over 12 would equal pi over 3, because 4 goes into 12 3 times. So it is, in fact, pi over 4 and pi over 3. So for this one here, we're going to say that this is the sine of pi over 3 plus pi over 4. I always write it with the bigger angle first. And therefore now we have the sine of a sum. So the sine of pi over 3 plus pi over 4, using the sine of a sum, is going to be the sine of pi over 3 times the cosine of pi over 4, looking at your formulas. Then the sine is going to be the same, so plus the cosine of pi over 3 times the sine of pi over 4. And now we have to remember the values of each one of these. The sine, which is the y at pi over 3, which is the 60-degree angle, is going to be the larger, square root of 3 over 2. And the cosine of pi over 4, square root of 2 over 2. Plus the cosine of pi over 3, the x value, the small one, 1/2, times the sine of pi over 4, which is square root of 2 over 2. When we multiply these together, we see we get the square root of 6 over 4 plus the square root of 2 over 4. And when we add them together, it comes up to be the same answer as the last one, which is square root of 6 plus the square root of 2 over 4. So that's going to be the sine of 7 pi over 12. Again, it's going to be odd looking answers, but since it says find the exact answer, It has to stay with radicals, has to stay using radicals. And each one of these is either going to be in degrees or radians. If you must, you can change your radian to degrees in order to find whether it's a sum or a difference. But in this case, we were able to find the angles and radians, so we'll go ahead and put them in. Now, example number 3 changes just a little bit, but it's going to ask us still to find the sum and difference and use the sum and difference formulas. Example number 3 says, suppose that the sine of alpha is 12/13. Suppose that the sine of alpha is 12/13. That's given to us. And then they say where pi over 2 is less than alpha, which is less than pi. What does that mean? That means that if alpha is greater than pi over 2 and less than pi, that means that this angle must be in the second quadrant between pi over 2 and pi. And then they say that the sine of theta is 3/5. Sine of theta is 3/5. And then they say where 0 is less than theta, which is less than pi. That tells me that this one, pi over 2. That tells me that this one is in quadrant 1. So we have two different angles, one in quadrant 2, one in quadrant 1. They give us the value of the sines. They want us to find now the cosine of alpha, is part A. They want us to find the cosine of theta as part B. And for part C, they want us to find the cosine of alpha plus theta. So we have to find the cosine of alpha. We have the sine. I know that sine is opposite over hypotenuse. We know it's in the second quadrant, so we're going to draw triangles to figure this out. So we're going to draw triangles for each one. This one is in quadrant 2, so I'll draw the triangle in quadrant 2. I know that this is alpha, so we'll put an alpha. And I know that the sine is 12/13, so it's opposite 12 over hypotenuse 13. In order to find the cosine of that same angle, we need adjacent over hypotenuse. So I'm missing this side. So what we have to do now is use the Pythagorean theorem and say that x squared, or in the case of this, we'll say the leg, because it's the leg of a triangle, the leg squared plus 12 squared equals 13 squared. So that gives me the leg squared plus 144 equals 169. When I subtract, I get the leg squared equals 25. And then we want the leg, so we take the square root of both sides. And the leg is the square root of 25, which is 5. So the leg is equal to 5 on that triangle. However, the triangle is in the second quadrant. The x value in the second quadrant is negative, so this becomes -5. Now that we have the three pieces, we know we can find the cosine of alpha. And the cosine of alpha is going to be adjacent over hypotenuse, or -5/13. -5/13. In order to find the cosine of theta, we're going to do the exact same thing, except we're going to be, for this one, in the first quadrant. So I'll draw this triangle in the first quadrant. It's a right triangle. This is theta. I know the sine, which is opposite over hypotenuse, opposite being 3, hypotenuse being 5. And we're looking for the adjacent side. Again, we're going to use the Pythagorean theorem, where we have leg squared plus 3 squared equals 5 squared. Leg squared plus leg squared equals hypotenuse squared. which gives us legs squared plus 9 equals 25. Bring the 9 over, legs squared equals 16. Take the square root of both sides, and the leg equals 4. So in this case, the leg equals 4. We're in the first quadrant. The x value along the first quadrant is positive, so therefore it's positive 4. Now we can find the cosine of theta. The cosine of theta is adjacent over hypotenuse, so the value is 4/5. So now we can find the cosine of alpha plus theta because we have all parts. Sine of alpha, cosine of alpha, sine of theta, and cosine of theta. So I'm going to go ahead and write down using the sum of a cosine, alpha plus theta, equals, and I'll go ahead and write the formula, which is what? Cosine of alpha times cosine of theta, opposite sign, so minus the sine of alpha times the sine of theta. Now it's a matter of us just putting the fractions in, so that's going to be the cosine of alpha, negative 5/13, times the cosine of theta, which is 4/5, minus the sine of alpha, 12/13, times the sine of theta is 3/5. And when I multiply them together, I get negative 20 over 65 minus 36 over 65. So when I take 36 from 20, from negative 20, I get negative 56 over 65. So that is the cosine of alpha plus theta. This is the different techniques that we're going to have to use for section 2.4. Remember, it's the formulas. We have to make sure we know the formulas, and it's a combination of the ordered pairs that we have learned in previous lessons. This concludes section 2.4, sum and difference formulas. I'll see you at the next one.